Okay. So I think there's a couple of types of interaction. There's touch. And then there's distance or point interaction. Thing that I'm going to figure out is how to differentiate between the two.
Limp, whereas it'll quickly get up to about a maximum of around, I think, 150 feet per second. So this was calibrated to be similar to a standard longbow. And of course, there's no hard assets or anything for the project right now. It's just everything here is made out of meshes in the engine folder, like cones and cubes and stuff like that. But so there's a little shooting gallery that is basically a classical increasing difficulty ramp where you have a certain number of lanes. Right now there's 10 lanes, and it will randomly spawn targets. You see that fading scroll bar or progress bar. Whenever it gets to 0, another target will spawn. And it's basically going to start filling up the lanes and get faster and faster. So each successful shot will increase the speed of the targets and decrease the interval. So it's meant to get about impossible after about 2 minutes. And there's a couple little things in here that are kind of neat. We'll see if Wes can get a perfect bullseye. There you go. When you get a perfect bullseye, you actually get 3 arrows. It's easier to use them at the end when there's more targets.
Yeah.
There you go. But just showing how you can do some simple little things like that with blueprint interactions. So this was a fun little project, and then West added some cool features in a separate little demo. He made kind of a tower defense horde game with some Infinity Blade assets. So we'll show that after we show the structure of how things are set up and just kind of go through a mini tutorial session.
Yeah.
And it's set up so you can grab with either hand, or at least it should be.
Yeah.
I'm sure there's a couple bugs here and there. It seems to be working all right.
And dexterous.
So we'll go over, how it's using motion controllers and different hand blueprints to be a little bit easier to script. And you can see it's just about filled up all the lanes with walls, which it doesn't actually fail you right now, but the thought was maybe after you get 3 of those walls up, that's a fail condition. And we would have liked to add a high score system or something like that, but didn't quite get time to finish it.
Yeah, I think we would spend most of the time kind of breaking down the mechanics, and that's what a lot of you guys are interested in. You guys can then build around that once you have the idea of how the mechanic was constructed.
Yep. So jumping right into the blueprint structure, give me 1 second to pull up the content browser. And so you can see in terms of the project, it's pretty basic. We have a gameplay and a weapons folder. And the gameplay folder is really just the character and the hands. So the character is the pawn, and the hands are blueprints that control the interaction for the left and the right hand. And there's a couple of reasons you might want to do it that way, especially when it's a state-based system like this where you have 2 hands that essentially do the same thing. And if you did all of that logic in the pawn here, which you certainly could do, you'd end up having 2 copies of all the variables, like a left grabbed actor or a right grabbed actor, and you'd be doubling the states. Whereas when you do it with the blueprints that are instances of each other, they both kind of behave the same, and they can be kind of aware of each other. And so kind of show you how that works right now. So the pawn is dead simple. This is the whole script of the pawn. Really no scripting going on here. Show you on the gameplay, we set the tracking level to floor, and all that does is make this work the same between Oculus and Vive, so that they're both tracked at the ground level. And then it does register the hand blueprints. And I'll talk about the structure of the pawn here first. You'll notice we have first up a scene root and then a capsule. And the capsule is just defining how tall the player is going to stand. So I have it, capsule height is around 96, so the character is around 200 centimeters tall. Some notes about how this is set up with the camera. All you really have to do to make an HMD camera is you add a camera to the pawn, and we'll have lock to HMD as an option there. You see that option, lock to HMD. That means it'll follow the camera. But you want to position that at the bottom of the pawn, which is why here we have another scene root, which I've renamed to HMD root. And I've moved that to, what does that say there? Hang on. Oh. Actually, I'm using this additional root in between. So this is at -96, which puts it at the bottom of the capsule. And the reason for that is that you can't move the capsule, or you want to keep the capsule at 0, 0. 0, and then just offset your root to be at the base of that for the Vive. And then the camera can be just relative to that 0. So now the camera will, wherever it is, will be relative to 0 of the pawn's feet, rather than 0 of the center of the pawn, which would put you too tall or something like that. So pretty much all we have is some scene roots and then a camera. And then underneath this same, let me hide the HMD, we have left motion controller and right motion controller. And those are really the only other two key pieces that you're going to have in a VR setup that'll pretty much always be there. And these are, you just add them here, left motion controller, or sorry, it's just called motion controller here. And I'm renaming them to left and right manually, and then make sure that you select the right one. You see this one is set to left, this one is set to right. And that's pretty much all you need to do for the motion controllers. And notice that I've added child actors. So underneath each motion controller is here's a left-hand child actor and a right-hand child actor. These are both just child actors added by doing child actor. And then we've specified them to be BP left hand and then BP right hand, which is a class of left hand, so that there's no custom scripting going on in there. Text render, this was just a debug thing I put in here to make sure that the height of my head was about where it should be, because it's easy to mess up by having missing scene root or something like that. And it's actually on, which we don't really need it, so I'm going to go ahead and set to hidden game right now, so it doesn't show up again. So that's pretty much it for the pawn structure. You'll notice here in the tick, this was that debug I'm talking about, just wanted to show the centimeter height of the head in the world, or actually this was the local tracking height, and just show that. Not really needed. So the only real script that's happening here is we have motion controller, left grip, and right grip are hooked up to pass some input to the left-hand blueprint and the right-hand blueprint. And all they're saying is grab and release. And that was just done that way so that I'm not worrying about consuming input or anything like that. You could probably have done that in the hand blueprints themselves, but that gets tricky because then it would have to be separate left click, right click inside these, which would mean the script is no longer agnostic inside the hand blueprint, which you want it to be pretty agnostic. Like whatever's happening, it doesn't care which hand it is, it just knows what hand it is itself. And so the fact that these left and right hand blueprints are here, notice we have variables down here. And that was done because you don't have access to all of the properties of a child actor without casting to the class, which is a bit of a pain. So I'll usually do that ahead of time, which is why in the very top here you'll have register hand BPs. And all that's doing is taking these already created left and right child actors. It converts them, it gets a child actor, because otherwise you can't cast, which always is a little weird to me, but I've just accepted it. And so we cast to the left hand type, and then we store that left hand as the left hand BP. And now if we want access to it, we could, tell it to grab or do different stuff, and we have access to all of its properties. And then same thing for the right, set it to be the right. But notice the right hand is still of class left hand, which is why they're both the same class. And one other little note here, inside of my hand blueprints, I have a property called other hand blueprint. And I go ahead and just, for the right one, I set the other hand to be the left. And that means that they can communicate to each other seamlessly as well. And for the right hand blueprint, I set it to be the left.
And those are properties you just created inside of the again blueprint. And you're passing those through at this point.
Yeah, sorry, I said it backwards. It's telling the left hand that the right hand is the other one. So that's all that does. It basically tells them about each other and makes the pawn have easy access. That's so far the whole pawn for this project. So we don't have any movement or anything fancy like that going on. So the hands are also pretty simple. There's really no script in the right hand. It's just an instance. So in fact, if we open it, notice it's just like a data-only thing with nothing changed, other than one setting, which is left hand. So that was the one thing that was changed in the left-hand blueprint, in the right-hand blueprint, and I'll show you how that works now. So this is the left hand, which is controlling all of the interaction for this. And you can see it's pretty basic. All it does is handles grabbing and overlap. So let me see here. The grab and release functions are over here, where they basically do some logic to communicate to the other things that you want to interact with. So I'll take a quick second right now to talk about why it's using that. It's using actually an interface. And interfaces are not super popular anymore because they're a bit of an older method of blueprint communication that was created before you had the ability to communicate directly between blueprints. But it's still useful in cases like this, where you want to do the same kind of action over and over again between possibly many different blueprints. And you wouldn't want to go through the trouble of creating these functions and always adding in an input for which hand, what am I doing, did I drop it? You'll spend so much time refilling out that information if you don't have an interface. So I've created an interface to do that here. And it's probably worth really quickly looking at the interface before going into too much how the hand itself works. It's a pretty simple interface, so don't worry. So we're going to go down here, back into gameplay, core, interfaces. And most of this stuff is just a little, helper like a macro and some material functions. There's not a lot in here. It looks like a lot of folders. But that's mostly because this was migrated out of a different project. So we're going to look at the player interaction interface. So this is when you first create an interface, there will be nothing here on this functions list. Then you add a function by, adding a function and adding in whatever new stuff you want to do, add in functions like that. And then once you add those functions like that, they'll show up here in this list of interface functions. And just a little thing, I'll tend to, even if I'm not using any variables, add some kind of return variable, even if it's just blank. Let me see if I can, you see here, this is one hand-end overlap. I just have this blank no-name variable here, and the only reason I do that is if you have a return variable, the interface functions will show up in this list. Otherwise, it's just expected that you have to actually create a node in the event graph for it, and I feel like that's not a super great workflow for me. So I like to have all of them here and just know what's being used. So I'll make sure they all have a return function. But generally, they're all pretty similar, and they're all just kind of passing basic input from the motion controller. For this one, all we're really using is grab pressed and grab released and hand begin and end overlap. We're not even using the trigger for this project, so I'll just show you guys those. So all we really care about for grab pressed is which hand. And that's actually an enum of left-right, and all it tells you was it the left or the right hand. And we have some other options, like was it dropped on release. And for grab pressed, it's similar, we have which hand, but we also have a reference to the hand blueprint, which is useful because when you grab the bow with the hand, you want to tell it what was the component to attach it to, and that sort of thing, or where is the sphere so it can check overlap. And there's some return options, such as the transform of the object, the hand, and or sorry, this could be where you return the transform of the object that's being grabbed, whether it was picked up or not, whether it was a secondary grab. And also, this is another option, local grab position, which isn't used here, but it's useful for if you wanted to do something like grab a staff and it had to be grabbed in a certain place. You could transform that hand to a local position and then adjust it as necessary and return it. And then the begin and end overlaps are pretty simple. Begin overlap, basically, again, it has the same hand blueprint and which hand, so it's left, right, in reference to the blueprint. And then it also passes in a selection material instance dynamic, and that's to make it easier for the hand to highlight if you have a preview material that glows or something, which we're using all of the bow and arrow stuff, like the knock will glow when you're going to knock an arrow, or the string will glow when you're about to grab it. Or sorry, I said that backwards. When you grab it, the knock will glow by your hand, and when you pull the string, there should be something with the string that glows, and it's able to just pass different instances in here, and then it can work without having a separate action for every type of material, for example. So that pretty much goes over that. It's just a way to pass in all this information to all, like if you added new weapons, you would just reference this interface. And for those of you who are not sure how to add an interface, it's down under class settings on your blueprint. You go down to implemented interfaces, and you can see I already have my player interaction interface, but we can go ahead and add a different one, which I won't do because I don't want to risk messing it up.
Yeah, but what's great about using the interface, it doesn't care what it is you're picking up. It just passes that information through to specify what type of object I picked up.
So I guess that's the bow. For the hand, I'm going to go back to the event graph. And rather than talk about the grabbing yet, first I'm going to talk about the overlaps, because that's kind of the precursor to grabbing. So we have here, you notice that my hand has a sphere, if I can get closer. It has a sphere collision. There it is. And that is set to overlap all. It doesn't block anything. But it's useful for figuring out if you have overlapped some other component. We'll go back to the event graph. So basically, the way you add events for that, let me bring up the settings. Oops. Sphere. If you go down here, you can add events. There's already one on component overlap, so now it's a view button instead of an add button, right? So that's how you add those, just to not glance over anything. So there's a couple little logic things that happen here, which are just to really avoid scanning the system and avoid confusing. So we have a little macro here, is other hand BP. All that does is make sure we don't ever do any overlaps where the hands overlap each other. But you think you wouldn't need to do that because you should set the collision profiles to avoid it, but it's better just to check it. And all it is really, is it not the other hand blueprint? Yes or no. You know, that's all. It's a macro that just checks that for you. And then the other thing is, we want to make sure that we're not already overlapping something, so that helps avoid, fighting over things. Technically, you probably add some sort of priority here, which I think is what Nick did for Bullet Train, but right now this is basically assuming when you overlap something, you can't overlap something else until you've ended that overlap, either by grabbing and dropping or whatever. So it's saying, is it not valid, to make sure that it only happens if there's nothing there, and then it sets this actor to, overlapped actor. So you notice here's the variables we have here. We have the pawn, which is a reference to the pawn, which we get on begin play. Other hand blueprint, which is a reference to the other hand, whichever one that may be. And that was set in the pawn on begin play as well. And then this other one is left hand. This was the one that was added so that we can support having a right hand without changing anything. And it's set to is left hand true, and it's editable, which means it can be changed on the other one. It doesn't have to be exposed on spawn because we're not going to change it after spawning, but it could be similarly. And then these are the secondary grabbing things, which is useful for pulling the string. And so these things, overlap and grab actor, is how it handles the state and how it makes sure it doesn't do grabbing multiple things at the same time. And they're both just an actor variable reference, as you can see up here. And some of these other ones are just little helper variables for grabbing things and transforming in the material instance array. So that pretty much shows most of those features. So at this point, we've overlapped something. Nothing is overlapped. So now we're setting whatever's being overlapped as the overlapped actor. I have debug text kind of spattered throughout here just to help. So you'll notice I have a function set debug text. All that's really doing is setting a debug text on the hand. Let me see. Yeah, it's probably hidden right now. Where is it? So yeah, I do that just because sometimes it's ambiguous what's happening. And I'll add that so it says we overlap something. But you can ignore that for now. And so now this is going to do the hand and begin overlap.
Okay. Now it all makes Okay. Oh, I get that. Let's see. Okay. So there's got to be here. There's got to be motion controller on. Base teleporter destination. There's got to be somewhere. Teleportation arc. Really? Teleportation cylinder is the missing. And teleport destination. Okay. Now get teleport. Then get orientation position. Break vector. Make vector. Get world location. Rotate vector. But nothing on the arc. I would love to know. Oh my goodness. I know. Wait. What's that? Hmm. Alright, so getting closer. There's a somewhere it creates ring around arc spine. We got the path positions. Here's where I think missing something here. I feel like we should be doing something right here. Pick a cube. Really. Okay. So this is the beam mesh. Found it. Where world grid material? Where does that come into play? making progress. Need to find. Beam mesh. Where is beam mesh applied to? That's what we're trying to figure out. Can I find beam mesh? Add a beam mesh. Oh, I don't want to do that. Okay, we did that. Oh, here we go. Hmm. Not currently streaming. Apparently, I'm not currently streaming. Hmm. Streaming on Twitch, nowhere else. Okay. Well then. Okay, so I see where that. Is. Something, I don't know.
So very simple stuff for picking up and dropping items. So this kind of setup here could be used for anything, not necessarily.
Best way to keep your performance reined in or keep your performance in check is to build something that's performant right out of the gate. And I'm going to go over a few things to keep in mind while you're making your content and a few experimental tools inside of Unreal Engine 4 that make optimization so much easier to do and so much of a less manual thing than would be another workflows and things like that. So let's go ahead and jump into it.
Yeah, I think we're going to jump in. We're going to show you the finished project, and then we're going to kind of walk through it step by step, how we did it. We'll walk through the whole project together so you can see all the bells and whistles and how we put it together. So we're going to turn it over to the screen here. I'm going to put this headset on and try not to lose my mic as I do so.
Or smash me in the face with the motion controls. It's horrible payback.
And I think there goes my mic off my ear.
Here, do you need some help? Here, you do that.
Okay.
You got them?
I think so.
All right. I have to move out of the way a little bit or I'm going to get smashed.
Although I am off-centered a little bit now. Let's actually reset this. Maybe. You gave it to me in the wrong hands. Here.
Oh, sorry.
There we go.
We need to label those.
Yeah, we sure do.
It gets really confusing. Which one's
So
the one?
let me go ahead and talk about what we got here. So first thing we got here is a simple carnival game. We got the traditional can toss. I don't know if that's the actual name for it, but
There's the can toss, milk bottle
milk
toss.
bottle toss. There's tons of variations of these. The North Carolina State Fair was in town not too long ago, so it got me thinking that'd be a fun little VR game since they took
Up. Yeah,
kind of
that was our
little part created. So let's just add part if I can actually have that appear so that you can kind of see where you're aiming. So we have a button on the left here. If we go over and press this button, it will restart the game. So I can go ahead and just not hit Sam in the face, press that button. And in the far back up there, we have a UMG widget. It's a 3D widget that is just an actor with a widget component added. And we'll step through that in a second here as well. So we have 3 balls here, and I can walk over to one of them. I can reach over and pick up, and it gets stuck in my hand there. There's Sam's nice material for his baseball there that we created. And obviously, if I just try to throw it at these cans, let's see if I can knock them down. So throw it. And that was terrible.
Dude, that was a perfect
throw,
hit,
too.
though.
Now, one thing I did want to mention about this is physics-based, and there's some things that still need to tweak on this.
We need to add physical materials to mess
Right.
with restitution, friction. Restitution is bounciness, in case you were wondering what it is.
Right.
To just give them a little bit more weight when it hits off of them. Because right now, like I said, it's purely physics-driven.
Oh, I missed.
Oh, look at that!
Get down there, I still lose. But you see, I lose up there. I had one more can remaining, but I could go over and try it again. And
Out of the way.
let's see. I'll give it one more shot here real quick. So it'll reset the game. And the intent is to have several booths like this set up. As we jump into the material stuff that Sam wants to talk about a little bit later, we'll kind of show you what we're planning to do here.
You'll see some of the games and some of just the rough framework that I put together to make this super modular and super reusable for VR. You know, you want a lot of asset reuse in VR to save on. Oh, look at that! It's almost like balling a cup.
Almost. Yeah, so I can switch hands. I can throw it with my left hand if I'm left-handed. See if I can actually do that. See if that helps. Oh, nope. Missed. The other ball fell on the floor and fell out of the play space here, so we deleted it. So we'll show you that as well. So let's actually take a look at the project here and kind of see how we set this up. So we take this off for a second. And put that down.
Somebody was asking. Yeah, there are actually wrist straps on these, and you missed it. I threw it across the room earlier today when I was setting it up. I was playing some slashing game, and it slashed right out of my hand onto the floor. So we've already dropped it once today. That's all you get.
I'm going to move this over here out of the way. So we're looking at the actual project now. Again, I just wanted to walk through this real quick before we jump into some of the other stuff that we're going to talk about here today. Again, if you have any questions, feel free to put those in, and we'll try to respond to those as we go. So the first thing that we did, we added some additional inputs for our character. We started out with the first-person template project just because it had a built-in kind of perspective that we wanted to take. It had some built-in functionality for us as far as moving. So we just added to that. We went up to the project settings here, went to the inputs, and added a couple additional inputs here.
We should actually talk about resetting this, the D-pad.
Yeah, I was going
okay.
to get there, right? You're getting ahead of yourself there. So as Sam was just going to mention there, I'll talk about that here in a second, the D-pad setup. So we have some action mappings. We have the right hand use and the left hand use. These are just bound to triggers. If you set up inputs before, you should feel right at home at setting up inputs for motion controllers. They're all right there inside of the drop-down. So if you click the drop-down, you can search for motion controller. If you could spell it. Yeah, like that. And you can see there's all the motion controller options right there that you can assign for the different buttons, for the triggers, for the trackpad, etc. So what we did, we just added the right trigger and we added the left trigger. There's also grip buttons on the side of this. There's a left and a right grip. And I did some experimenting with that. I know Valve is working on the final, I guess, what is it, the final product, the version of this controller here that's going to be a little bit more easier on the hands to hold, I guess.
More ergonomic.
Yeah, I didn't want to reference any other products, but they're working on a better version of this. And holding the grips right here, sometimes you would hit the trackpad. I found that distracting, so I put it on the trigger just because it was easier.
The grips are also a left and
It is.
two separate
It's
buttons.
two separate buttons. That was the
Even
other
though
thing.
it feels like one button, there's
Right.
a button on the left and a button on the right. So just be wary of that when you're trying to set them up.
Yeah. So as far as the actual movement, like Sam mentioned earlier, we when we were working on this project, we set it up in about a day or so. Half of the day was spent trying to figure out why I couldn't move backwards. And after some research, I figured out what the problem was. The touchpad on here, first of all, is touch sensitive, so it's kind of like a iPhone if you...
Or it's like a laptop.
Yeah, kind of
like a little thing like like this right here. It's exactly like this little trackpad right
So it's very sensitive. You don't have to push and click it, although there is a push-click as well. The general movement is done by the touchpad itself. So I could move forward, but I couldn't move backwards, and I didn't know why. It was only giving me 0 or 1 values, access values. I wasn't getting negative ones, so I couldn't move backwards. And after some research, we found out that we needed to recalibrate the touchpad. And you can do that by holding the trigger and pressing the little black button on there. That'll allow you to reset it, and you should give you that full access.
It does make a beeping noise once it's been recalibrated.
Yeah, there's also another one for repairing if you accidentally unplug your USB or need to repair it for any purposes. You can press the
drops out. For
the little black
reason.
button and the red button together. That will give you a different sound as well. Let you repair it.
And then it'll be repaired, and then you'll see. So you can go back over to the screen. You'll see the compositor that we've got both motion controllers up, and then the 2 squares are for the lighthouse trackers.
Mm-hmm.
The red thing is for the headset, and it's not on, so that's why it's giving us a little bit of an error there.
So the only thing that we did for the access mappings, we just added an additional input for the motion controller for the left thumbstick. If you're at home with working with gamepads at all, it's going to be very similar. So we just set it up very similar here to the left thumbstick here. So we're moving along the y-axis here. And for moving right, we did the left thumbstick and the x-axis. So that is our left stick movement. And then the right stick, this is totally optional. We just did the right thumbstick along the x-axis here.
Yeah, and I wasn't really sure how being able to turn and using I thought that was going to induce motion sickness, or simulation sickness, I'm sorry, and it actually works out really well. I really prefer it like that.
Yeah, because then you don't have to turn your head to move in a direction. You can just kind of be in the environment and move around.
Like the lazy Wii.
That's how I like my VR, okay? So with all of our inputs set up, the first thing that we did is went into our first-person character here. This is our pawn that we are controlling. And we need to add components for this, and we covered this in the previous Twitch stream. We added some components. You can go to the components window up here, click add component, search for motion controllers. Not the Leap Motion, unless you're working with Leap Motion controllers. Just the regular motion controller here. Once you assign that, then you can go to the details panel and define which hand that motion controller corresponds to. So there's some other options in here. We haven't had to mess with those too much when playing with motion controllers. It's really just this section.
I think a lot of this stuff is just the way that Unreal works. You get a lot of other things like, cast shadow and things like that. So when you do the motion controller component, as Wes said, it's literally you just set one up for the left and then one up for the right. Ours is L motion controller, R motion controller, and that's literally all you have to do to get them set up. And then attach a mesh to it so you can actually see what's going on.
Yeah, because there's nothing. If I go to the viewport here, you can see our little character.
That's
his little
awesome.
boxy hands. Obviously, if we had a skeletal mesh, we would use hands and make it look a little bit better.
We were working on that, but other things came up that we had to jump on for another project we're working on. So we'll have hands eventually. It's one more thing to add to the pile, right?
Yep. So I'm just going to step through these components real quick. All we did was to provide a way for us to pick objects up. We created a collision, and whenever that collision overlaps something, that tells us, if we're in range to actually pick up the object. So we just created a box collision here. Our box is pretty big. If you had, like I said, hands or something, you could use spheres or whatever you'd like for your collision. And then there's our mesh representing our hand. I also added an arrow component. I use this arrow component, again, because we are not using skeletal meshes, as a way to define where we want to attach the objects that we pick up. If we had a skeletal mesh that had bones in it, we could have a bone specifically for gripping items or something like that. We could attach it to a particular bone. But this gets the job done. So we just added an arrow component. And then finally, there's our particle effect, which is off in the viewport here because it's activated when we hit our trigger. So that's kind of how we set up our components. We did the same thing for the right hand, so we just set up the exact same way. We have both hands that we could use if you're left or right.
Did you want to duplicate it, or did you just
I duplicated the components. Unfortunately, I can't right-click and copy and then paste all of these just yet.
Okay.
But the settings will carry over for each one that you use.
All right. So
I created all the components that I needed and then just nested them. You probably could have also nested them directly under the motion controller so that everything follows along with it. But for clarity, I nested them under each other so I can collapse and do things like that.
That makes sense, right? Separate the right and the left.
Yeah.
It makes it easier to debug, too, if there's ever a problem.
Now, the other thing I did, just because when testing this, I shrank the size of the collision capsule here, just so it's a little bit narrower because it was wider than my actual body. So I would go up to...
colliding in.
Right. I'd go up to the little stand to pick up the balls, and I'm like 5 feet out, and I can't reach it. I couldn't figure out why. I was like, then collision's hitting it, so I need to get in a little bit.
Horizontally challenged.
I think that's it, yeah. So on the event graph, there's not a whole lot we did here. Actually, there is a little bit, but we'll get through it real quick here. First thing that we did on the event begin play here, we set it to follow our HMD orientation here. We just did that by getting the controller and the camera manager here. We set that to true. Now this is if you want to independently move your head while moving. If we left this off, our whole body would turn along with the camera, which we didn't want. So
it makes it really hard to pick things up.
Yeah, so this is just a matter of preference, how you want to set it up. For the stick input, here's our turn rate. This is our right thumbstick here. This is very similar to what was in the template, actually. We have a variable here that controls how much, at the rate at which we turn. If you've looked at the first-person template at all, this should look very similar, actually, because it's kind of the same setup. For the movement input, we're just using the move forward and move right that we set up and plugging those access values directly in. Like I said, the real meat of this blueprint here that we made changes to was actually picking up objects, determining when we are in range to pick up objects, what happens when we pick them up, etc. So we'll hop down to that section real quick. So we have our right hand pickup here. And what we've done for this is, here is our input action event for our right hand use. So whenever we press the right trigger, which we define this as, first thing we're checking is the Boolean that we created, is our right hand in range? Can we actually pick up an item? Otherwise, we'd be able to pick it up from anywhere in the world. So it's pretty straightforward there. This Boolean is actually being set when our collision overlaps an object. So here is our onComponentBegin overlap for our triggers. So this is the right trigger that we are searching. When we overlap, first of all, we're checking, do we have something in our hand already? Because we don't want to pick up a ball if we already have a ball in our hand. So that's the first thing that we're doing. If either of those are true, we're not going to do anything. If we do not have a ball in our hand, then we're going to make sure that it is the ball that we are actually picking up. And this is a separate blueprint. It's just a static mesh. It's just a ball. It has some script in it that we'll take a look at in a moment, but it's very, very simple. Once we determine that it is a ball, we're going to save that as a variable so that we have reference to it for later. And then we set that right hand in range is true so that we can actually press our right trigger and pick up the ball. Now, when we actually are able to pick up the ball, we have a custom event that we created that's called Pick Up Ball. And we added some inputs on it. The first thing that we added is our hand, quote unquote hand, which is our right arrow, and the ball to hold. And the ball to hold, as we mentioned, is being set here when we overlap the actual individual balls. And once we go through this script here, we'll hop over to that in a second. We then say that a ball is in our hand so that we can't pick up balls again. And then we activate our little particle effect here so that we can see where we're aiming. If we are not in range, we also set the particle effect to activate just so that we can test out without holding the ball to see where we're aiming. So that's why we set that there. For the actually picking up the ball, if I double click on that, we'll jump to that. All we're doing is attaching it to that arrow component. So our hand is the arrow component right there that we've set. That's the parent. The target is the actual ball. And then we are snapping and keeping the world scale. So it is now attached to our arrow that moves along with our motion controller. Very, very simple stuff here. As far as dropping the ball, when we release the right trigger, first of all, we want to make sure that we have a ball in our hand. Otherwise, we could drop nothing, or we could set that we are no longer holding a ball, and all kinds of funkiness is there. So we want to make sure that we do have a ball in our hand before we can drop it. If we do, then we're going to call this drop ball here. We're going to specify the ball to drop, and we're just detaching it there at that point. So we're detaching from the parent, maintaining world position. We are detaching the ball, and we're also going to set simulate physics to true so that we can drop the ball in air and it fall down to the ground and react as you would expect. The reason we didn't set physics on by default, one of the things I noticed, you walk up to the table and go to grab a ball and accidentally knock it into the play space and lose that ball.
Yeah.
So the balls are static by default, and then you can go and pick it up. Once you release it, then it turns into a physics object. So very simple stuff for picking up and dropping items. So this kind of setup here could be used for anything, not necessarily balls. It could be guns. It could be
actually
bats,
any object in the world that you want to pick up or put down.
Right. And let's see what else we have here. So the rest of the script down here is for when we overlap and stop overlapping our balls here. So that's the right hand. The left hand is an identical setup. We're just swapping out the left arrow, setting which hand a ball is in, etc. That's pretty much it for the player character. Everything is set up to pick up and drop balls at that point.
They're like, oh, that's typical Carney game logic. You hit one ball. No, you only got two left. Sorry, you got to buy more.
Yeah. So the way we went about setting this up, everything is modular so that we can take all of these bits and pieces and repurpose them in other Carnival games that we want to try to create here. So we have this scoreboard, which is its own blueprint. Well, that's a wall, but our actual scoreboard here is its own blueprint. Our reset button is its own blueprint. The balls are their own blueprint. The cans are their own blueprint, etc. And then we have a little dinosaur hiding under the table. And this dinosaur is the main blueprint that controls the logic of this game.
Would say maybe like the parent, I guess?
It governs the rules, essentially. So I could take this piece and just plop it down somewhere else. So if I go, here it is, the can game blueprint, I can just take this down, plop it somewhere else. It has triggers and everything in it so that I can move the triggers around.
And then we use the eyedropper over there to pick what we want to use within the world.
If I get rid of, I don't know if we're going to lose our...
just pull it over
Yeah, I'm going to pull it out. I don't want to lose our... So here's our details panel. I'll just remove it from the other side here. It has some properties in it set up for us so we can define...
Alrighty.
Just use the eyedropper as Sam mentioned. I can specify to click the drop down, pick which scoreboard because we could have multiple instances of this. Same with the reset button. It's better to reset this particular game, not any other game that we could potentially have. Now there's some other variables that we exposed. We exposed the cans remaining, max cans, the number of balls that we wanted to have, etc. There's also some parameters for adjusting the size of the quote-unquote scoring area and the out-of-bounds area. I think it happened once during the demo that I was showing a moment ago that I lost a ball because I dropped it and it fell out of our little play space here. So we need to be able to track what happens if you throw a ball out of the play space. So that's why we set that up there. So let's take a quick look at the ball blueprint because it's really quick. It's very similar to the projectile actually because we're creating an impulse at the point of impact. This is something that I'm still kind of playing around with how much impulse to create. So I noticed if I set it too high, then the cans go flying. If I set it too low, then they don't move at all. So still kind of messing and tweaking with these values here, but we're just making sure that it is a can that we hit. It's not another ball that we're hitting and generating impulse on, etc. So that's the script here, and it's just a static mesh. That's all it is. So that's our ball blueprint. The can is probably the most simplistic blueprint that we have. It's actually just a static mesh. The can. That's
I'm like, wow, that is really simple.
There's no script in here.
I was like, then he's going to go to the construction script and it's going to be huge.
Nope, that's it. It's just a blueprint, simple blueprint actor. Let's see what else do we have. The scoreboard. I'll take a quick look at this. So we have created through UMG a widget. So here's our actual widget blueprint. And I didn't want to go into too much detail about this UMG setup here. We'll cover it real quick. So we just set up a simple vertical box. It has some text in it for the amount of balls remaining, some instructions. We set our UN text to hidden by default. We're turning that on through script. We'll show that in a moment. And then we have some text for when the game is restarted, etc. We set some of these to variables so that we can drive these through blueprint script. Now, there's no actual logic being handled inside of this widget blueprint. If we go over to the blueprint actor, which we've created a simple actor, all we've done for this, I maximize this, is create a widget component. If I go to the viewport,
Okay.
so it's just a widget component so that we can place this in 3D space. I think we've done some Twitch streams on this as well. There's a couple how-tos on the official documentation pages as well, how to set this up. I think it goes even more complex than this. It's a menu, like a main menu in 3D space. If you want to check that out, feel free to check that out. But we created a simple widget here, made some minor adjustments to it in the details panel here, just increase the draw size so we can see it a little bit better. And other than that, we have the script in here. This is all the script for updating this is being handled in that dinosaur blueprint.
Ah,
So
okay.
I'm going to close this out. And let's actually hop over to that, because that's the real magic. So there's a couple sections in here. We'll cover this, and then we can wrap this up here. So the first thing that we did, we added 2 components. If I go to the viewport here. Or 3 components. First component that we added is just a box collision that we're using for our scoring area. When a ball lands in this area or a can lands in this area, we're treating that as the scoring area. Then we also created the out of bounds volume. So when I leave this volume, then we can destroy the ball so that we don't have balls floating off in space, etc. And then I added a marker just so I could see it a little bit better. So with all that, let's take a quick look at the event begin play here, and then we'll talk about some of the logic for scoring. So the event begin play here, this target score blueprint is a variable that I created so that we can specify through that picker in the level which scoreboard we are referring to. So this is how we do that. It's just publicly exposed variable here.
And the reason we did this is to make it easier to reuse. And basically, was to make one blueprint that I could then take and set up in an entirely different way, but still have all the same scoring functionality and logic and things like that. It's just a better way to work when you have to work with multiple people.
And once we've created that reference to it, we can then get the widget component associated with it. So it's referring to this widget here.
Okay.
So it's getting this now. And I've seen this on the forums and Answer Hub a couple times. How do I actually access that widget and the functionality for that widget if it's an actor? You need to get the user widget object. And once you get that, then you can cast to your UMD widget blueprint. And then you can access all the functionality from it. So what I did is I just created a variable for our widget blueprint so that I can reference it a little bit later. Created a quick function here to initialize the display. And all that does is get the balls remaining and cans remaining, calculate the variables so that it gets updated whenever we start our game. And then we have our target reset button. Now, we actually didn't look at this blueprint, but we can take a quick look at it because it's really, really simple. So here's our reset button, which is right here on the wall. Open that up. And again, this can be dragged and dropped and used in any of the Carnival games that we try to create here. It's just a static mesh representing the button, text renderer component, which kind of was a cheap way to do this, but tells you what to press. And then we created a trigger. And when the player moves his arm into this trigger volume and presses LT, that will signal a reset. And we're checking that right here. When overlapping the trigger is the first person character. If it is, we're going to allow input to be provided to this blueprint. When we leave that trigger volume, then we no longer want input to be received from this blueprint. So when input is enabled, we can press the left trigger and call an event dispatcher. And then we're going to destroy the actor, just to kind of give us a visual indication that we've pressed the button. Down the road, we'll change the material of the button to green or something to let you know that you've pressed the button.
It's an iterative process,
Yeah,
right?
And I need some kind of visual cue that I pressed it, so we're deleting it for now. So this event dispatcher, if I hop back over to the actual can game blueprint here, we are binding that now to a function in here that will reset our game essentially. So we bound it, and we can call begin restart here, and begin restart will update our scoreboard, let you know that we're going to restart the game, starts a countdown, etc. Begins counting down, and then once it reaches 0, actually we are just reloading the map again. Down the road, we'll set it so that it wipes everything and respawns everything in its correct location. But for now, just attach it to restart the map. Let's see what else we have here. I think we're looking at the actual landing in the scoring area here. So first thing that we do when we land in the scoring area, we're checking is it a ball that landed in there? If it is, first thing we're going to do is turn off generate overlap events. I notice is we don't want it to re-trigger multiple times if the ball's bouncing around in there, so we turn that off. Then we update our display for the cans remaining, we display that on the HUD, and then we call a function called all clear check. So we're checking to see have all the cans been knocked down at this point. Each time a can lands in there. So we can call this, and all this does is say if the cans remaining equals 0, if it is, then we're going to set the game over text essentially to visible and say that you won. If it is not, then we are not going to do anything. When we are landing in the scoring area, we're checking to see if it's the can. If it's not the can, then is it a ball that landed in there? If it is, then we're going to decrement our balls remaining, and we're going to call a function that updates our remaining balls that we have to use. And that's just the display right here. Once we update our display, then we're going to check and see if we are actually out of balls at that point. And all that's going to do is say, similar to the cans remaining are all the balls, you have 0 balls left. I added a little bit of a delay here rather than once you are out of balls saying game over, just because you can throw a ball and there could be a can kind of teetering around on the platform and then kind of fall over.
Okay.
So getting a little bit of a delay before actually saying, hey, game's over.
They're way nicer than
Yeah.
an attorney.
Yeah, it's still kind of difficult, but realistic, right?
Yeah, that's true.
So this is all very straightforward stuff. And the last bit of business that we do is, if we are out of balls, we determine that no, we still have cans remaining, then we're going to say that you lost. So that's really the gist of it. There is one little thing that we did, when a ball leaves the play space, so on in overlap, so we've thrown a ball and we've thrown it over the wall, essentially, mentioning the ball, then we're going to destroy the actor and say that the ball is destroyed. The ball is destroyed is just going to hop right up here to the script, decrement our balls, and run that same check, how many balls we have left, setting the display, etc. So that's really it. I mean, it's all physics-based. It's nothing too complex here. Again, I haven't had that much experience with motion controllers just yet. We got this up and running in like a day, really quickly. So,
And if you do notice, I'd say almost 99% of this is just standard blueprint functionality. You notice the only thing that we had to do to get the motion controllers to work is just make sure that we had the motion controller component added to it, and that we had that on our first-person character. And that literally, that's it. Like, it's so awesome to be able to work with something
very easy,
that's
yeah.
super easy to set up and basically set it and forget it.
yeah, a lot of the stuff that's shown here is very entry level. If you've had any experience with blueprints or any experience with generating overlap events, this stuff is very easy to set up. And hopefully, when we have a finished version of this project, you'll be able to see for yourself and kind of think over it, make it your own. How are we doing on time? How are we doing on questions?
Actually, so if you guys have any questions, please put them in the chat. I actually only have 3 questions so far.
Okay.
So let's jump into the questions, and I'll jump into some material and optimization stuff. So the first question I have right now is: are there any games that have implemented a 3D space mouse on a 2D curved screen? I want to have a mouse drag around I want to have a mouse drag around UMGs around the character, so the surface is inside of the sphere. But I have trouble doing this in UE4.
Yeah, I kind of get what he's after. He's kind of after a virtual reality menu navigation type thing.
Like a screen like this.
Right. Even if you had like an inventory, like there's an inventory tutorial series out there. If you guys have seen it, the drag and drop functionality. He's looking for that in VR space. So having a motion controller and being able to kind of move things around. I haven't actually experimented with that, but I love the idea, I love the concept. So that's maybe something that we can experiment with, trying to roll into these carnival games that we're working on here. Maybe we have some kind of simple match 3 thing where we can in VR space grab something and pull it and move it.
Oh yeah, we can do something like that.
A simple thing like that, something like that. But I don't have an answer for that right now because I haven't experimented at all with myself. So maybe something that we can.
It sounds feasible.
Yeah,
it's
it
just
sounds feasible.
Something we need to just work out and figure out how to get it to work. Okay, so the next question I got here is: in my game, I add child actor components that are attached to each motion controller on construct. These are my base hands in the game. I want to be able to switch other blueprints that have their own meshes and fire their specific projectile blueprints based on which one of the Hydra buttons is pressed. What's the best way to hot switch child actors? And are there meshes and there are meshes but still have general trigger actions work across the board? Basically, I think he wants to you throw down your ice hands,
right.
Your fire hands.
Right. Yeah. There's a number of different ways you could go about doing this. It's really going to be handled in your communication, just how you communicate with your different actors. Probably what you would want to do is have those not necessarily be child actors of something, just make them their own separate entities, their own separate actors, and then have a variable that you can drive through script and update, kind of like what we were doing here. So you have a trigger volume, and you go to mouse over something to pick something up, populating that variable at the time that you overlap. You could get what actor it is that you've overlapped, pass that through an interface or direct blueprint communication. It just depends how you want to go about setting it up. But I would look at the blueprint communication as how to pass that information between. It's totally feasible. Maybe that's something that we can experiment with.
Yeah,
Alright, so they don't actually talk about. I just wasted 30 minutes waiting for them to talk about the laser. And they didn't actually talk about it. So what I'm trying here. To see if this does anything. was actually pretty fast. Works. I'll be right back. Okay, that did not work, but I have to get out of here. So after all that, it did make a little bit of progress. So that's let's see if I can continue working on it tomorrow. Let's see. So then here.